Alright, our front triangle is completely assembled, and now we're going to have to face the ends of the head tube right here and right here. We've got some scrap right here that's a little bit more than I want to cut off with the facing tool, so we're going to hacksaw this off of here first. And then over here we have a lot of scrap sticking up above the seat lug, and I'm going to grind that down close to the seat lug. So I'll go do those two operations, and we'll be right back to do the head tube facing. Here we have the head tube reamer and facer, and first we'll slide the facer into the tube. We're going to face the worst end first. This end is a factory end, and it's nice and square. This is the end that I just hacksawed off of here. So always do the worst end first. I'm going to use this as a spacer. This piece is a head cup press plug for this tool, but this is such a tiny bike that I'm going to use that as a spacer. Then the washer, the spring, the keyed washer. Most of you will notice if you have a Campagnolo tool set that there's a yoke-shaped nut that goes on here. I usually take the nut off of the bottom bracket facer and use that here because it's a lot easier to use. The reaming and facing tool is another tool you never turn backwards. So make sure that you don't turn this backwards at any time. Again, we're using the chlorine-based cutting oil made by Rigid. As I mentioned earlier, I cut the excess off of here with the hacksaw. Do not grind the excess off of here with a stone, because if you grind the excess off here with a stone, you're going to have little particles of stone hanging around inside your head tube, and those little particles of stone could dull your cutter. You'll notice that every now and then I reach down toward the big nut and I just grab it for a second. I'm tightening that up each time I grab it. Some people will tell you can only go a certain speed with these cutters. I heard one person say you can only go 18 RPM with these cutters. I have no idea where they came up with that number. These are high-speed steel cutters. They're made for cutting chromoly steel. They'll cut mild steel. They'll cut chromoly and anything less. And the cutting speed of steel ranges from 80 to 100 feet a minute. And if you compute that with this cutter can probably be turned over 300 RPM without risking any damage to the cutter. We've reamed all the way down now, and now the facing teeth are coming in contact with the end of the tube. What we're going to do is we're going to cut this until the end is nice and clean, and we have one continuous surface between the end of the tube and the end of the lug, so they kind of blend in and become one piece to the naked eye. You can tell when you're cutting, you're getting nice chips coming off of there. Remember again, this tool does not get turned backwards. Turning this tool backwards will dull it. Sometimes you'll start seeing one chip that'll be coming off of here in one nice long curl. And when it comes off in one nice long curl, you know you're going all the way around the tube, and that curl happens to be that one. There we are. We're getting a nice long continuous curl. Now what I do is I back the big nut away, back it away, back it away, and I take a finishing cut. Back it away, take a light finishing cut. And there we go. Continuing to turn it in the same direction, we'll pull it out. And if we take a look at this, we've got Nice, continuous, shiny surface. Excellent. Now we'll flip this over and we'll repeat it on the other end. Right now we're going to check the fork crown. This fork crown has not been cut yet with the fork crown race cutter. Right now it's at a 29.6, which is way too big for a road bike, obviously. A lot of crowns have a large diameter right there. Henry James gives you a tighter or smaller diameter down there. Henry James gives you about a 27.3 or 27.4. This particular crown is an Everest crown, and we're going to have to cut that down from 29.4 or 29.6. This is a VAR crown race cutter. I actually prefer this over the Campagnolo cutter. It has a flip-flop cutter in it. There are several of these available. This particular flip-flop cuts Japanese on one side. That's a 27.2 right on this side. And it cuts the Italian on this side. It's cutting a 26.5 on this side. So we're going to cut the larger of the two sizes. You'll also notice as I drop this in, there's a little depression right there. And that depression should go right behind that threaded hole. And we've got a set screw that goes into that threaded hole right there. And we'll take a little Allen wrench and snug it. Just notice how I'm snugging it with my fingers. Don't torque that, because you could risk cracking your cutter. We'll slide this over gently, don't drop it. This is the spring that comes with the tool. This is the top half of a dummy headset, and I'll explain the dummy headset later. Push down and set it. Okay, now grab our cutting oil here. This is another tool, you never turn backwards. I took this tool and I drilled an oil hole in the side so I can stick my cutting oil in through the side. It makes it a lot easier to keep this thing filled. Just squirt it in there until we see it squirting out the bottom. And this one takes a while. Cutting down from a 29.6 is quite a hefty cut. You're probably wondering, why has this guy been doing all of his work with Campagnolo tools and all of a sudden he changes to a VAR tool? Campagnolo tool sitting right here. I use the Campagnolo tool for the finishing cut. Do not attempt to make your initial cut with the Campagnolo tool, because I can almost guarantee that when you're all done, it's going to be cut undersize. Start with the larger end of the VAR tool. Cut it to a 27.2 first. It's going to take quite a while to go down. We've got to go down about 5 more millimeters, so you can figure I'm making a career out of this. Every now and then, squirt a little more oil in, and continue. Here we are, we're at the bottom of the cut. Pull this off, and we'll take a look. It's clean all the way around. We've got a good cut there, no chatter marks or anything. Now, this is cut for the Japanese size. I'm making this bike to take an Italian size headset. So what we're going to do is we're going to flip this cutter over like so. Tighten it up. Again, just with the pinkies. Now we're going to cut this thing to a 26.5, which will be a really tight fit for a 26.4 headset. This will be a lot easier cut to do this second time around, because we're only cutting about a 1/2 millimeter or so off of this thing. Before, we were going from a 29.6 to a 27.2. Now we're just going from a 27.2 down to a 26.5. That's less than a 1/2 millimeter. Okay, we're at the end of our cut. We're now cut to 26.5. Now this is where I use the Campagnolo tool. And over many years of building hundreds of frames, I have discovered the best way to get down to that 26.4 press fit is to take your Campagnolo tool, Campagnolo crown race cutter, and cut fast and dry. That's it. Now let's get the go no-go gauge and check that out. Here's Campagnolo's go no-go gauge, and the go side is the side without the stripe, the no-go is the side with the red stripe, and all we do is we slide this onto the steering column. The go side should drop right down and hit the crown, and the no-go side should not go on at all. That will not go down. If it goes on one side and it doesn't go on the other side, you have a press fit with a high quality 26.4 headset. Alright, these are dummy headsets right here. These are the bottom halves of the dummy headsets. I've got 4 different types of dummy headsets. The first 2 are for 1-inch diameter steering columns, and you'll notice that they're quite noticeably different heights here, and these also are quite noticeably different heights. This set right here is for a short stack headset. This set right here is for a tall stack headset. So the 2 areas on here and here add up to 40 millimeters. These 2 areas from here and here and here and here add up to 32 millimeters. So this is for short stack, this is for tall stack. I'm building this bike tall stack. And incidentally, these 2 headsets back here, this one's for 1 1/8" steering columns, this is for 1 1/4" steering columns. Both of these would be used in lugless construction. Alright, what we're going to do is we're going to take our fork crown that's been all cut to size, and we'll drop the bottom half of that dummy headset over it, and then we'll go over here and we'll stick it in the frame. We'll slide the top half of the dummy headset over it. And you can see that we've got a little bit of a problem here, and that is that our threads end right here, about 1 centimeter above that dummy headset. And we want to go down to about here with our threads. So we're going to add about 25 millimeters more threads onto what we already have here. I'm going to cut right here, right there. I'm going to cut right there, and then I'm going to add 25 millimeters of threads from here to about here. And the reason I'm going to cut a little bit above where the threads end is these original threads will help me start the tap. So don't cut off all of your original threads. You need to use them to get your tap going. So let's go over and put 25 millimeters more thread on here. This is another tool that I prefer over the Campagnolo tool. This is the steering column die in the center and the die holder. There are a couple of reasons I prefer this over the Campagnolo. Number one, it's a very versatile one. You can take the guide out of here, and you can take the die out of here, and you can get different sizes to fit different size steering columns. For example, here's one for 1 1/4". That's the guide. And here's the die for 1 1/4". and you can also get them, you can get a 25 by 1 for French. You can get an 1 1/8 cutter for mountain bikes, and you can of course get the British one. Slide the guide over first, and you'll notice, as I said earlier, I left about 1 centimeter of threads there, and I cut them off so they'll be about flush when I turn that down. There we go. I just hit the bottom thread and I'm flush right on top, and I want to put 25 millimeters of extra threads on here. That means that when I get done, I'll have 25 millimeters sticking up. Let's put our cutting oil down in the flutes. Same cutting oil as before, chlorine containing for working with steel. And I back this cutter up quite a bit. I'll back the cutter up about twice per revolution. And the reason for backing the cutter up, there are a couple reasons to do it. A lot of people talk about backing the cutter up to break the chip away. That's one reason, but it's not the most important reason. The geometry of the cutter will break the chips away, but backing it up will also aid in doing that. The really important reason for backing the cutter up is because when you're cutting these teeth, these threads, the very, very front of the cut is like a little furrow, and it's like running a plow down a farmer's field. And when you back up, it allows the cutting oil to flow right into the forward portion of your cut. If you continue to go in one direction and you don't back up, you're going to have a hard time getting lubrication down there for cooling purposes. So, do a lot of backing up. Unfortunately, I've found that the Campagnolo steering column die makes beautiful threads on the way down, and they have nice shape to them, and the nut screws on quite nicely, and then it shaves them all off on the way up. And my Campagnolo steering column dies sit in the Campagnolo box, and I've learned over the years never to be tempted to take them out and cut new threads with them. They will chase old threads okay, but don't trust them for doing new threads. Okay, here we go. We have 25 millimeters of thread sticking up beyond the cutter. Remember, before this part was sitting flush with the cutter, and now I've got 25 sticking up. So I've added 25 millimeters of threads to this steering column. And if you've turned it back and forth, back and forth, back and forth enough, you should have a nice set of threads when you take this cutter off. Alright, we have our steering column with new threads cut on it. Slide our dummy headset in place. There we go. And if I was going to be using a standard road set with side pull brakes, I'd cut this even with the end of the top of the dummy headset. However, I'm going to leave a couple millimeters extra so that we can have room for a brake hanger. Sometimes people say, oh, how do you make a straight cut on a steering column? Well, the big key is to have a nice sharp blade. If your blade is wearing out, don't hesitate to replace it. A nice sharp blade is going to make a much straighter cut than a dull bent blade. Now I'm going to stop here before the end of the cut. It's very important when you reach the end of the cut that you watch that you don't skid your blade down the top tube, which can happen. So start watching that steering column. As you get to the end of the cut, it should start kind of opening up for you. So watch for that steering column to open up a little bit and ease up on your cutting so you don't skim down your top tube. Take a peek, see how you're doing. Almost there. There we go, it's opening up. That's it. Here we have our steering column cut to rough length. There are a couple of ways that we can clean the top of that off, and I'm going to use an 8-inch half round file to do it, which is my favorite file. One way is we'll put the dummy headset on there, and as we file it, we can look to see how close it comes to the dummy headset. The other way would be to put a machinist square on there and crisscross it like that and just get all 4 of your readings to be the same height. Either way would be just as accurate as the other. So start doing that. Maybe we'll do it with the dummy headset in place. A little high on this side, a little low on this side. Okay, when you get the end of this as square as you want it to be, then you're going to file a little bit of a bevel on the outside. Just a little 45-degree bevel all the way around the outside like this. And by doing this, this will get your headset parts to screw on much more easily. Just file that burr off of there. Then for the inside, so as not to score your stem, this is a deburring tool. You can get these at most machinery and equipment stores. Just go around like that and take the burr out of the middle. And now let's take a look and see how we can file the keyway. Lots of people ask, how do you cut the keyway in the steering column? And there are a couple ways to do this. The easy way would be just to take your steering column, clamp it in the vise, and just file a flat rather than a keyway. However, it's very hard to find a washer to go along with that flat. It used to be possible many years ago. The French washers worked quite nicely. But those aren't available anymore. So what I found is if you take a top nut from a headset, preferably in steel because it won't wear away on you as you file it, and cut a notch in it. I don't know if you can see that notch. Let me hold that up in front of my hand a little bit better. I've got a notch cut all the way through that nut so that we can screw this nut onto the steering column. Remember, the keyway always goes at the back of the fork. And put that split nut on there. And then take one of those safe files that we talked about earlier. This is the one that the edge cuts, but the face has been sanded clean on the belt sander. And you can simply go through there like that. But let's get another angle at this so you can understand it a little bit better. And here we go. You just do your filing right there with the safe file and the split nut, and you just file about half the thickness of the crown, and you should have a nice straight keyway when you finish. Let's take our fork crown and steering column assembly, and with our hole on our hole and our keyway on the back, we're going to put our fork blades in. And when we put our fork blades in, we have to make sure that the name on the fork blades is on the outside, not on the inside. Then we'll put this on our wheel. This is a Framebuilding wheel, by the way. I call it a frame building wheel because it's never been on the road. I only use it for frame alignment purposes. Now I'm going to measure right here, and I can see that I have a distance of 55 millimeters between the top of the tire and the underside of the crown. I've got 55 there. Now the customer has required, with a 700 by 38 tire, he wants 1 centimeter or 10 millimeters between the tire and the crown. So if I have 55 and I want 10, I go 55 minus 10, 45 is what I cut off. I like to mark for my cut with a vernier height gauge, and the vernier height gauge has a nice scribe right on the end here. And what I'm going to do here is I'm setting this at 45, and then I just hold my fork blade up on edge, and with that scribe on the vernier height gauge, I'm just going to go right around the fork blade, and I end up with a nice line at exactly 45 all the way around. Do that with both blades. You can also do this just by hand with a hand scribe, with a carbide scribe. It's about the size and shape of a Bic pen, but this is much more accurate. Now I'm going to drop this down a little bit. I'm going to drop this down to 44, and I'm going to make another line parallel to the first. That way when I make my cut, I'm going to cut right down between the two lines. This blade, I always use my thumb against the side of the blade to keep the blade from jumping. And when the cut gets underway, then I move my thumb away. Always take a nice long stroke when you're hacksawing. That way you'll use up all the teeth on the saw. People who use little short strokes here wear out the middle of the saw. Check to see, make sure we're going down the middle of those two lines. Going nice and straight. Take it easy at the end here so you don't hit your knuckles on the vise. Now put this in the vise, and we'll just carefully clean up the end with an 8-inch flat file. Take the burr off around the outside. And you may as well take the deburring tool, take the burr out of the inside. There we go. Do the same to the other blade. Assemble your whole fork assembly here, and check out. Hopefully you've got the right amount of clearance there. We're shooting for 10 millimeters there. Notice we've got a bigger gap here, smaller gap here. That means that this blade is slightly longer than the other blade. So we're gonna just very carefully take a little bit off the top of this blade with the 8-inch half-round file, just to sort of fine-tune the length until we get equal measurements on those two sides. Right now we're going to mark for our air expansion holes in both the chainstays and the fork blades. So we'll set them out like this, and we'll use an automatic center punch. Those are available from quite a few different places. This particular one is made by Starrett. They make 3 different sizes. This one's the biggest of the 3. And then we're going to mark for our air expansion holes in the fork blades. I'm marking these about an inch to 1.5 inches away from the dropout. And I'm putting it on the opposite side from the name. Make sure that the air expansion hole is on the inside face, and of course the name is on the outside face. There we go. And then we're going to have a couple of large holes on the inside face of the tops of the blades. And those will be about 1/4 inch down. Those are also for air expansion. I'll show you how they work later. Okay, let's drill our holes now. I'm drilling with a 7/64 drill bit here. That's what I usually use for my hole at the end of the seat stays, chain stays, and fork blades. If I'm building something heavier like a tandem, I use an 1/8 inch air expansion hole in those locations. Now we'll change the bit and we'll go to 1/4 inch. Alright, this is a 1/4 inch hole that we'll be drilling into the top inside face of the fork crown, or the fork. There we go, there's one. Make sure that these holes are going on the opposite side from the name on the dropout. There's the other one. These are the holes that vent into the fork crown. At this time, you should take your fork crown, and there may be burrs left inside there from when you ran the die grinder inside that socket. So take your take an 80 or a 100 grit emery cloth strip and sand any burrs out of there that happen to be in there. We have our air expansion holes on the inside face of the blades and at the top as well. You'll notice that this hole right here vents right through the fork crown and up into the hole up inside the steering column. Now we're going to go clean the inside of this socket with Snow Bowl, and we'll also clean the outside of this blade with Snow Bowl where the pieces are going to meet together. Alright. We're in the fork jig right now, and I'm checking to make sure that the dropouts lie flat against the ends of this dummy hub down here. And I'm going to take a dropout out, over to the vise, and bend it just a tiny bit, and take it back and put it in. That's much better. Now I'm going to tap gently, make sure those dropouts are bottomed out. Again. Quick release so they won't go anywhere. And I'll tighten this. I've got a gauge on the inside surface here, right there. You probably can't see it from that angle, but there's a gauge there that tells me the exact amount of rake. I've got this set for 55 like our drawing. Then the next thing I need to do, I need to make sure I don't have twist in my fork. So I made this bar with the indicator on top of it. I can see right off it's got some twist, so I'm going to remove a little bit of it right away. And I'm going to set this at 0. Okay, I'm between 6 and 7 down on the tiny dial and on the 0 there. Flip-flop it, and we'll take another look. And I've got to move it a little bit to split the difference. I'll reset my 0. Very close to the 6 on the little tiny dial and right on 0 on the big dial. Check it again. About 5 thousandths difference when I flip-flop from one side to the other. So that's looking really good. We'll set that tool aside. Then we're going to mark for a hole right here, because we're going to put pins in here to hold this fork to keep it from creeping. 16th inch drill bit. Carefully wipe these shavings off of here. You don't want those shavings in your flux. Get all those shavings out of there. They'll look really nasty if they get caught up in the silver. And first let's take a little piece of 16th inch welding rod. Don't hammer it all the way in, or you'll have to disassemble this whole thing to get that thing out of there. Have that little pin sticking out about 5 or 6 millimeters. We can clean that off after we're done brazing. We'll drill the hole for the other pin. Of all the things on the bike, it's really critical on the fork not to have any creeping taking place during brazing. And these pins eliminate that. Again, wipe those little bits of shavings off of there. Pound the other pin in. There we go. I neglected to mention that this fork has already been fluxed and cleaned and fluxed. It's all ready to braze right now. Our fork crown is kind of a massive piece, so it's going to take us a while to heat that up. So be prepared for a fairly long preheat. Might want to take the telephone off the hook for a while. These pins will tend to get red on you. Try not to get them too red, because the flux will get bad around anywhere that you get red. Try to catch any flux that falls on the ground. It's been my experience that a fork like this with integrated tangs is going to take between 10 and 11 inches of silver. In fact, I know from experience that a Henry James crown, which is like the one I'm doing on the other frame that I'm building right now, will take almost exactly 11 inches of silver. Go ahead and you can go ahead and make a tack right there. We got a nice heavy tack right there, and we'll go over to this side and start heating this side. It's kind of tough to do these because they are a blind hole. As we did on the lugs, we were able to see the silver coming out the other side. We don't have that luxury here. We can't see what's happening to the silver on the other side of the joint. So we just have to go by experience. And I guess the best indicator that I found is the length of the piece of silver that you use. And as I said a minute or two ago, be prepared to use 10 or 11 inches on this crown. Okay, we'll tack this one heavily. Sucks it right in. Okay, let's flip it over, and I'll do the back sides. It's always handy to have a fixture that you can see through right here. I actually got this idea for this fixture from Talbot's book, Talbot's Framebuilding book. He had a plywood fixture in his book, and he had a hole in it for doing the back side of the crown. I thought that was a really nice idea, so when I built my fixture out of aluminum, I put the same hole in that Talbot was using. If you want any other hints on frame building, you might want to check Talbot's book. It's not in print anymore, but I'm sure you can get it maybe in some of your local libraries. We're just going to add our silver right along the edge of the crown, and it's pulling right in beautifully. These windows on the sides of the crown, let's take a look at this window right here. Let me flip over. If you want to, you can use the window. If you have windows in your crown, you can use that to add your silver. It's a nice handy place to add silver. The plus of having a window is the looks. It looks kind of fancy to have that little window in there. Also, if you want, you can use it as an area to add your silver. The minus part of having a window is it might accidentally fill up with too much silver on you. I kind of like to hop around as I do the crown, same way I do other joints. I don't like to do just one spot all at once. This area right here, it's kind of hard to get silver down in that area, so you got to make sure and apply your heat down inside here. That inside face, down low, away from the point of the tang, way down at that base, hard to get to. Make sure to add that extra amount of effort in that area. This is really taking the silver with quite a good appetite. And we're right up to the end there. Let's go over to this side for a while. And do this side in here. In case you're interested in a set of fixtures, in my latest edition of my book, there is a set of plans to make your own fixtures almost exactly like the set that I use here, and it's right in the body of the book. I'm not sure exactly where in the book it is. It's probably put at the end somewhere, but that's a book that's available from Henry James. Also, don't forget that Henry James sells a complete set of frame building fixtures. He has the front triangle fixture, rear triangle fixture, and the fork building fixture. It's all in one. It fits quite neatly into a park stand. This side is also taking silver quite nicely. Oh, right over the top. I got some cleanup for myself. come back over here and redo this one. I don't think we've added much silver in this side yet. Of course, if you don't get enough silver down inside here in this area on the inside face on the tang, you may be looking at some frame failure further down the road. Of course, we don't want that to happen. But the fork blade, if you don't get enough silver down inside here, the fork blade could separate from the tang and you might end up with a catastrophic failure. So make sure to get plenty of silver down inside there. Other jigs that are available, you can check Nova Cycle Supply, and Nova sells the Nortak jigs, N-O-R-T-A-K, I believe. Work on the other way. Now we're getting a little bit of buildup inside our window here, so we need to heat up and pull that buildup away from the window. You don't have to worry about these pins anymore. Those pins are firmly silver brazed into the fork now. Pull this stuff down low, heat up way down here. Now let's finish up this. We've got 3/4 of this done. We haven't added enough silver on this front part of this one yet. This was that first quarter that we did. You see it pulls a lot down inside there. No trouble getting that stuff to go in. Okay, we're getting kind of a big blob in the window here, so let's go to the window and clean up that little window. Actually, we don't have anything down in this corner of the window, so let's drop a little into the window and take it down to this lower left corner. Right down in there. We're looking good. Now I'm just going to go around the joint and inspect with my flame to see that I've got everything filled up. We've got a little bit of a gap here, so let's fill it. It's easy to fill a gap or take down a blob at this point. Much easier to do it right now than it is to have to reheat later. The windows look nice. And back here, everything looks pretty good. And it looks like we have a little bit of a blob here. And there we go, we've got a finished fork. And next we'll be cleaning up the seat cluster. We're going to clean up this area. As you may recall earlier, we cleaned off this piece of scrap up here with the grinder, and now we're going to finish by doing some filing. I'll be using mostly a 6-inch and 8-inch Nicholson half round. Basically here we're just going to go up and make sure that the lug and the tube are exactly the same length, so the tube ends just where the lug ends. The two of them should disappear into one piece. It should appear that both of them are only made up of one piece. Put a little angle on this. We want to have this pretty much a finished joint at the time we put our whole seat cluster together. If it's not a finished joint, we don't want to have to go in there and do a bunch of cleanup after our seat stays are put into place, because that'll be a lot of trouble. So we're looking at making this look completely finished at this point. Take the burr out of here. We still have quite a bit of burr left over from doing that grinding. I'm not filing that off square. I'm kind of giving it a bit of a taper. I've got the rough work done. Let's switch to a 6-inch half round. Okay, then we're going to take I'm going to use some 60 grit, 1-inch wide emery cloth strips. Just pull it underneath my thumb. Some of you may have a bleeding thumb by this point. If so, a fabric band-aid on the end of your thumb will do wonders to ease the pain. And there we go. We have a nice finished looking joint. We've removed all of the file marks with the emery paper, emery cloth. And that joint is all ready to attach the seat stays. As you may have heard me mention during the brazing session, I got a bit of a gob of silver over the top here. If you have any gobs of silver over the top of your lug or over the top of your fork crown or bottom bracket shell, take a little time to remove these. When those things get covered with paint, they really show up. I'm just using a 6-inch half round here to get the major part of it. And then I'll finish up with a piece of emery paper, emery cloth. Take the rest of it off with this. This is the touch that they don't give it at the factory. This is what makes a custom bike truly unique, is that final hand touch and special attention you give to detail. There we go. And just kind of go around the rest of the crown, cleaning up stuff. We've got those pins. Those pins are sticking up. We need to get rid of those. Most of them, about 3/4 of them, can be just clipped off. And we can get that last little quarter. Obviously, we don't worry about the part of the pin that's sticking on the inside of the fork. And do a final sanding with some emery paper, emery cloth strip. I keep calling it emery paper. I'm sorry. There is emery paper that's available for some polishing maneuvers. I can't think of really anything that you can use emery paper for on this in this frame building. I'm recommending that you use strictly emery cloth because of its flexibility, and it's quite a bit more durable than emery paper. And we have a little bit of a blob on the inside face here. I think I'll take a stab at it with my file first, because it does have a bit of thickness to it. And again, finish off with the emery cloth. Yeah, that's looking good. Let's do our inspection and cold setting now. All right, the first step of our fork inspection is going to be to check our spacing here and here. This can be pretty much a visual inspection. Just look for the same amount of spacing on both sides. Now, if you have more of a gap on one side than the other, it'll be you'll probably have to pull a dropout, and I will show you how to pull a dropout after we get the whole fork all aligned and straight. But notice that we've got good spacing on each side. So let's go over to the alignment table. Let's slide this into the fork inspection jig. Basically, there are inspection fixtures and there are alignment fixtures, and sometimes if you make your inspection fixtures heavy duty enough, they can also be alignment fixtures. We'll put our 6-inch machinist square up against the back of the blades near the top. We'll slide it down, put it against the back of the blades near the bottom, and I can see that I'm going to have to bring this blade toward me. Now we'll use the park tool for that. This fork is pretty springy, so I gave it quite a tweak. There we go. We're looking very good on both of those. Now, this is a little fixture that I made right here. This is for making sure that the blades are equidistant from the center line over here. So this has been set up to match this center line. So this is going to have to come up a little bit. Pull against the crown. and the other one has to go down. This is where forks might fail if you didn't get enough silver in. And this is where you'll find out. Could come up a little bit. It takes about 1/10 of the force to bring it back again that it takes to move it in the first place. So we have basically 3 inspections to make. One is fork twist with the square against the tops of the blades and the bottom of the blades. The other one is fork ends or dropouts away from the center line, which this takes care of. And the third one is fork blade length, which the wheel takes care of. And we already took a look at that, but let's double check it again after everything's all straight. After we get done checking that, I'll show you how to pull a dropout if it's necessary. I decided to do just a tiny bit of dropout filing on this, and that filing that I did, is right in this area, right here. It won't do you any good to file in this direction and filing deeper in the groove. You basically have to file in this direction, down into that part of the groove right there. As a rule of thumb, if you have to move the fork, if you have to move the tire over 1 millimeter or less, you can do it by filing this area in the dropout. If you have to move the dropout over 1 millimeter, you'll have to warm up that dropout and pull it. And if you have to move it over 1 millimeter, 2 or 3 millimeters, you're best off to remove the other dropout, refile the slot, and rebraze it in. Those are your 3 options. If you have to pull a dropout, this is the tool that I use to pull dropouts. I call this a dummy wheel because I can simulate the wheel diameter here and I can simulate the wheel width here. This is a 100 millimeter width and a 700C diameter. To pull a dropout, say if we were going to pull this dropout over here, we would heat with the torch, heat this area. I'd put some flux on it first, then heat this area, and as that's heating, I would apply pressure with my fingers at the top here, very even pressure, until that dropout pulls out a little bit. Now remember, always remember, what you pull down here is magnified by about 3 times when it gets up here. So if you pull that dropout out a full millimeter down here, it's going to appear as a 3 millimeter change way out here at the wheel. So pulling dropouts is very exacting work, and it may take you 3 or 4, maybe even 5 times of pulling that dropout in and out to get the 2 at the same length. One thing that's very important about pulling dropouts is you have to let the hot dropout cool before you check it in the wheel. Because if this side is hot and this side is cold and you stick it in the wheel, then this side is longer and it's going to be inaccurate. So checking it in the wheel has to be done cool, and don't dip it in water to cool it off. This is the rear triangle fixture right here. The rear triangle fixture holds the front triangle and a dummy headset which holds the completed fork in place, and if those items are held in place according to the proper angles, then we can build the rear triangle. This tool right here is called a miracle point, and boy, I don't know if you can get one of these anymore. Made by the Cullen Manufacturing Company in Sturtevant, Wisconsin. And this is probably the best angle finder I've ever found. I have seen them on occasion in used tool places. If you can't find one new, try to find one in a used tool shop. It's extremely accurate. If you can't find one of these, then you can probably use one of those Craftsman angle finders. This one's magnetic, and so I stick it on the only part of my rear triangle fixture that's steel, which is the backing plate. I've got it set up with a little magnifying glass, which I can read. And that's sitting right at 0. That's perpendicular to this, and it's sitting right at 0 degrees. So the jig has been leveled. We can put it on a seat tube and read that. Now I can see that that's at 74 degrees, which is what the customer requested. On a really short bike like this, it's difficult to get the head tube, so we're going to put a little steel bar on there and just hold it on the head tube. And I can see we're at 71.5 there, which is where we're supposed to be. That's what the customer requested. There's a scale right back here, and this scale gives bottom bracket drop. And this is a touring bike, so we want a low bottom bracket. 7.5 centimeters bottom bracket was requested. It's exactly where it's sitting. The front triangle, we can measure that right here. We've got, it looks like around 59.5 for a front, excuse me, not a front triangle, but a front center. We have about 59.5 for a front center. And to adjust for the front center, I was able to loosen this large bolt right here and move the axle post back and forth. Frame is held in place here at the front axle and over here at the seat tube, and it's kept on center line with this bar right here. This bar is just the right thickness so that it holds the frame exactly the right distance from this backing plate. This is all ready now to cut and fit the rear triangle. I just checked the job sheet here, and we need to set the rear triangle. It's going to be a really long rear end. It's going to be 46.5 centimeters for the rear triangle for the chainstay length. So we'll loosen this post up and we'll move it to right there, 46.5. The main reason that you go with such long chainstays on a rear triangle of a touring bike, number one, for heel clearance on the panniers, and number two, the chain alignment is a lot better for you know, if you're using really wide ratios with really a lot of selection of gears. The chain alignment is great on a longer rear end. Now, first of all, if we take a look down here at the bottom bracket shell, you can see that these are not fitting in there at all. They're way too tight. So the first thing we're going to do is we're going to ream that out of there with a die grinder with a stone on it. So let's go get that die grinder. Okay, you'll definitely want to use hearing protection while you're doing this. It's going to make a lot of noise. We're using a stone that's rated at 25,000 RPM, so I'll be running this at full speed. We're going to go inside the bottom bracket shell right here. When we do this, we want to keep this in nice in line right along here between the axle post and the bottom bracket shell. We don't want to wallow it out like this, or we'll really ruin that hole. So we'll keep it nice and straight while we're making this hole larger. This is a Henry James bottom bracket shell. And should be plenty sturdy for touring uses. That drops in there beautifully. It slides in. It's a little bit difficult sliding in, but when it drops into place, it feels like it's a perfect silver solder fit. There's just a little bit of wiggle down at the bottom bracket shell, and it easily drops into place. Now we'll do the other side. Same maneuver. We're looking really good here. That was probably the easiest reaming job I've ever done. It went quite easily. Now we're going to take a look right here at the axle post, and we can see that the dropouts are not setting flat against the end of the axle. Incidentally, this dummy wheel right here is 135 millimeter width. This customer is going to use a mountain bike rear end on this touring bike. We need to bend these dropouts, both of them, in a little bit so that they sit flat on the ends of that axle. So we're just going to take this out of here. We're going to go over to the vise, and we're going to give that a little bit of a bend. Very good. Now we'll do the same on this side. A little bit more. It's easy to overdo it when you make that bend. Up at the top, you don't want to bend more than half an inch or so. Looking good. Both dropouts lie flat against the sides right there. Now we're going to take a carbide scribe and scribe right here so we can get our chainstay length. We'll be taking about 2 centimeters off this chainstay. If I wanted to, I could have gotten about a 48.5 or 49 centimeter chainstay out of these. Make a really good mark here. And basically we're just going to go to the grinding wheel. Well, we'll hacksaw it first. We'll rough cut it with a hacksaw. Then we'll go to the grinding wheel and we'll rough that in on the grinding wheel. Okay, we've got 2 well-fitted chainstays. If I stick my finger on the inside of the bottom bracket shell, I can't feel either of them poking through. The two dropouts are bent so they're parallel back here. The holes here are reamed out so that I've got a nice silver solder type fit here. The next thing we have to do, since these are round chainstays, we're going to have to indent somewhere in through here for the width of the tire. So we're going to take the radius of the tire, which is 35, and we'll mark that. Got a radius right there. The outer portion of the tire is going to be right where I put the two marks, which means that the widest portion of the tire is going to be a little bit out from those two marks. So let's take a look and see what kind of width we've got there. Right there is about the widest portion of the tire, and it looks like we have a width of 40. 40 is not wide enough. We're trying to set this up for 700 by 38s. So we're going to have to dimple right here and right here. So let's mark a spot for a dimple. Our dimple is going to be between the marks on both stays. And let's take a look, see what a dimpling tool looks like. This is one type of dimpling tool that I use. This one is basically shaped like a chisel. Put that in the milling machine and put two bevels on it, and then I rounded it. You don't want to have a sharp chisel point when you do your dimpling. You want to have a blunt, rounded point. I've also got some relief cut in here so that I can dimple one chainstay while the other chainstay is in place. So I can actually dimple after the frame has been built. And I just use that as a large punch. I still use this one on things like heavy-duty tandem chainstays, things that have cross sections that won't fit my dimpling tool. Here's my regular dimpling tool over here. This was made by a guy named Vince Bowden in Golden Valley, Minnesota. I don't know if he wants to make any others, but you can always give him a call. I'm going to set this up so that my dropout is perpendicular to my dimpling tool, halfway between the two marks that I made on the rear triangle jig. And I'll just take that in. I'll put a pretty good sized dimple in there. Does a really nice job. The part that does the dimple is rounded, and the other part is also rounded to cup the outer portion of the chainstay. And there you go, if you can see that. Nice dimple. We're probably going to extend that about 3 times as long as what we see right now. But I'm going to dimple the other chainstay right now, and we'll take another measurement just to see how we're doing. Here's the other chainstay. Same procedure. Halfway between my marks. Now if I measure this, just those 2 little dimples gave me a clearance of 50. So I'm doing quite a bit better on my clearance, my tire clearance in through there. Let's also take our rear wheel and check out our clearance with a rear wheel. Okay, our dimple is in just the right spot right now. You can see it follows the curvature of the tire just right on both sides. However, I think I'm going to take it a little bit deeper. Okay, now I'm taking my dimple a little bit deeper, but I'm not going to make it any longer. we're going to have to do this bit by bit because there will be ripples in that dimple. Okay, let's take a look and see what kind of clearance we have. We have 55 millimeters of clearance here for our dimple. I think that should give us enough. That'll be, the customer wants a 700 by 38, and with 55 millimeters of clearance, that means that we're going to have 10, 17, we'll have almost a centimeter on each side of the tire, which I think is a great plenty. Let's see how it looks on the tire itself. Okay, there are our dimples. They follow the contour of the tire just right. Now let's put a dimple in the outside of the right chainstay for a little bit of extra sprocket clearance for a granny gear. Let's just briefly recap what we've got here. We've fit the chainstays into the bottom bracket, and we've bent the dropout straight so that they meet the dummy axle back here. We've not done anything to the seat stays yet. The seat stays are just dropped into place at this time. We might want to take a quick look at this little fitting here. This is a stay rest, and this allows me just to drop my stays in place so that they lie against the sides of the seat lug in their proper location. I can raise and lower that for different sized frames. Alright, let's take this left stay and start cutting the slot for the dropout. So let's go over to the vise. This is pretty much a repeat of what we did earlier. We're just going to cut a couple slots. Straight down about 8 millimeters, and then grab my trusty needle nose pliers, which are hanging up on the floor, and break those pieces out so we have a nice wide slot. For this one, I'm going to be using my 8-inch flat file, and we're going to widen that out first. And we'll go over here and check it. This is going to be a process of test and check until we get that thing fitting. Now that the bottom of the left stay has been slotted so that it fits the tab on the dropout, we're going to mark this left stay with an L, and it's going to be on this side. That way, if we put it on like this without the L showing, we know we've got the stay backwards. Let's take a look down here, down at the dropout. That tab on that dropout is not necessarily leaning at the right angle, and so I had to run the file through there at a slight angle to get that slot so it'll drop onto the shoulders of that tab. And if I turn it around the other way backwards right now, it won't meet that dropout correctly. So now we have to keep an eye on that L right there to make sure that we've got that seat stay on there correctly. Now we're going to cut the scallop, the decorative scallop in the end with the round file. We're putting the seat stay in there 90 degrees from what it was to cut the slot. This is basically a repeat of before. I'm putting that scallop in the end. And of course this is a decorative scallop. You can skip this step if you want. I want those 4 little points to be nice and sharp when I get done. One thing you want to make sure that you don't do is when you're filing, you don't want to accidentally go over the top, because when you go over the top, you really mess up those points. Now we're going to take a piece of emery cloth and we'll clean up all these burrs around the outside edges. We'll take another round file, clean out the burrs down inside, and that one will be all ready for brazing. Cleaning up these burrs is pretty easy. You can use anywhere from a 60 to a 100 grit emery cloth strip. And there's our finished piece.